Hello everyone, this is Shambhavi, your physics master teacher. So in today's session, we will be discussing about 2 mark and 3 mark questions from the chapter Units and Measurement. Okay, so this session is mainly focused on practice question. So we'll be taking certain, PYQs we can say, or some questions from question bank, and we'll be discussing in detail. Okay, so let us begin with the 2 mark question first. So here is our first question. What are basic units? Give one example. So, e question ali we have to define what are basic units and one example ಬರಿಬೇಕು. So, basic units ಅಂದ್ರೆ ಏನು? The units for the fundamental or base quantities are called as basic units. Okay. So, the units which we use to measure or to express the fundamental quantities or the base quantities are called as basic units. Okay, so basically there are 7 basic or fundamental quantities. So corresponding to those 7 fundamental quantities, we are going to have 7 fundamental or basic units irutte. So yavadadru ಒಂದು mention ಮಾಡಿದ್ರೆ ಸಾಕು. So like meter, which is the unit for length, then we have kilogram, which is the unit for mass, and then we have ampere, which is the unit for current, and we can also consider like temperature, which has the unit like Kelvin, and so on. Any one example. Okay, but that should be a fundamental or base quantity. Okay, I mean base unit. Okay, so moving to next question. Write the SI unit and dimensional formula for moment of inertia. So ಈ ಕ್ವೆಶ್ಚನ್ ಅಲ್ಲಿ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾಗೆ SI ಯೂನಿಟ್ ಮತ್ತೆ ಡೈಮೆನ್ಷನಲ್ ಫಾರ್ಮುಲಾ ಮೆನ್ಷನ್ ಮಾಡಕ್ ಹೇಳಿದ್ದಾರೆ. ಓಕೆ, ಸೊ ಬೇಸಿಕಲಿ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಹೇಗೆ ಬರಿತೀವಿ, which is usually represented by the symbol I, can be given by the formula mr square. Okay, moment of inertia I is equals to mr square. Okay, so in detail about moment of inertia you learn in rotational dynamics. For now you consider moment of inertia is given by the formula I is equals to mr square, where m is the mass of the particle and r is the perpendicular distance of the particle from the axis of rotation ಆಗಿರುತ್ತೆ. Okay, so from this we can now write down the SI unit. So ಹೇಗೆ ಬರಿಬಹುದು? So SI unit of moment of inertia. So ಇಲ್ಲಿ mr square ಅಂತ ಇದೆ. So mass is measured in kg in SI system, and r square ಅಂತ ಇದೆ, that is like length, which is measured in meter. So kg meter square is going to be the SI unit of the moment of inertia ಆಗಿರುತ್ತೆ. Okay, next ಏನಿದೆ, dimensional formula ಕೇಳಿದ್ದಾರೆ. So that is the dimensional formula of moment of inertia I is equals to, so ಇಲ್ಲಿ m andre enagutte, that is represented by capital M in the dimensional notation, and r square andre L square. R is length, right? So it is having a dimension of length. So m L square and t raised to 0, because there is no dependency on the time in moment of inertia. Okay, so enagutte dimensional formula for moment of inertia m L square t raised to 0. Okay, so SI unit baradre 1 mark, and the dimension baradre 1 more mark, so totally 2 marks. Okay, hope it is clear. Moving to next question. State the principle of homogeneity of dimensions. So in question ali we have to state the principle of homogeneity of dimensions. Okay, so basically in physics, okay, if you are adding or subtracting the physical quantity, we can only add them or subtract them if they are going to have the same dimension. Okay, we can add or subtract the physical quantities which are having the same dimension. That is what is the principle of homogeneity. Or in other words, we can say that in any equation, okay, the dimensions of all terms on either side of the equation must be same. Okay, so in other words, principle of homogeneity na hege helbodu. So it is like the dimensions of all the terms which are separated by a plus or a minus, or there might be an equal symbol. Okay, so they should going to have the same dimension. Okay, or in other words, we can also say like the dimension on left hand side of the equation must be same as the dimension on the right hand side of the equation. So this is something called as principle of homogeneity. Okay, so is that clear? So moving to next question. Give any 2 limitations of dimensional method. So in question ali we have to mention any 2 limitations of dimensional method or dimensional analysis. So let us have a look about the limitations. So one we can mention like the method of dimensions can only test the dimensional validity but not the exact relationship between physical quantities in any equation. Okay, so hangandre enu, by the dimensional method we can check the correctness for the equation, only the dimensional consistency we can check. Okay, but it is not going to tell us like whether the equation is really correct or not. Only dimensionally it is correct we are going to get from the dimensional analysis, but the actual relationship we are not going to get from that. Okay, so that is one point. Second point can be mentioned like dimensionless constants or the value of proportionality constant cannot be obtained by this method. Okay, so if we have some dimensionless constant in the formula, okay, we cannot able to get the value of that constant. Okay, so next, the equations involving trigonometric, logarithmic and exponential functions cannot be derived, because we know that these trigonometric functions, logarithmic function or the exponential functions, they are all dimensionless. Okay, so if some equation is involving some terms of trigonometric or logarithmic or maybe exponential function, okay, as they are dimensionless, we cannot able to derive such equation by using dimensional method. Okay, so next point in baribodu, the equation cannot be derived where addition and subtraction are involved in the equation. Okay, if a formula is just having multiplication or division form, we can arrive at that particular equation, but if it is involving addition or subtraction, then we cannot able to derive that from the dimensional method. Okay, addition athwa subtraction terms idre we cannot able to derive that. Okay, so any 2 points is enough for 2 marks. Okay, if it comes in 3 marks, please mention 3 points. Okay, so moving to next question. Mention any 2 application of dimensional analysis. So ee question alli ಏನು ಹೇಳಿದ್ದಾರೆ, we have to mention the any 2 applications of dimensional analysis. So one we can say like to check the correctness of an equation, that is the dimensional consistency check ಮಾಡಬಹುದು. So ಯಾವುದೇ equation if it is dimensionally incorrect, then that equation is 100% wrong. Okay, so we can check whether the equation is wrong, okay, by doing dimensional analysis. Okay, but it doesn't mean that if it is dimensionally correct, it need not to be 100% correct equation. But if it is dimensionally incorrect, then 100% the equation is wrong. Okay, so that is what we call it as dimensional consistency na check ಮಾಡಬಹುದು. Okay, second point ಏನು ಬರಿಬಹುದು, to derive the relation between different physical quantities of an equation. Okay, we can actually derive some equation or formula derivation ಮಾಡಬಹುದು. Okay, that is the relation between physical quantities andre enalli. So we can derive certain formulas, okay, by using dimensional method. So third point ಏನು ಬರಿಬಹುದು, to convert a unit of physical quantity from one system of unit to other system. Okay, so if we have a unit in one system, okay, so for example Newton is the unit in SI system, so I can convert this unit to another system of unit like CGS. Okay, so dimensional analysis help us to convert unit from one system to other system. So for 2 marks, any 2 point is enough, and if it is for a 3 marks, we can write down any 3 points. Okay, so we'll move on to next question, that is write the dimensional formula for the quantities impulse and power. So ಈ question ಅಲ್ಲಿ 2 physical quantity ಕೊಟ್ಟಿದ್ದಾರೆ, we had to write down the dimensional formula for them. Okay, so first ಏನಿದೆ impulse ಅಂತ ಇದೆ. Okay, so impulse, which is usually represented by the symbol J. Okay, so impulse J, it is given by the formula force into time interval, F into delta T anta ಬರೀತೀವಿ. Okay, short interval of time ಅಲ್ಲಿ large amount of force apply ಮಾಡಿದ್ರೆ, so ಅದನ್ನ impulse ಅಂತ ಕರಿತೀವಿ. This is also going to be equal to change in momentum ಆಗಿರುತ್ತೆ, that is delta P. Okay, so impulse is equals to force into time ಅಂತಾನೂ ಬರೀಬಹುದು or change in momentum. So ಈ notation ಇಟ್ಕೊಂಡ್ರೆ dimensional formula ಏನು ಬರೀಬಹುದು, that is J is equals to, so force dimension ಏನು, force is mass into acceleration, so we get m L T minus 2 into change in time or time interval andre it is just going to have the dimension of time t, or this will simply give us the dimension of impulse is equals to ml t power minus 2 plus 1 will just give us t power minus 1. Okay, so if you just take the change in momentum notation also, you get the same dimension, that is ml t minus 1. Okay, so next irodu power. Power can be given by work done by time, rate of doing work. Okay, work by time or energy by time anta helbodu. So ಈಗ dimension baradre, let me just write here, dimension of power is equals to, so work done dimension ಏನು m l square t minus 2 ಆಗಿರುತ್ತೆ, because work done ಅಂದ್ರೆ force into displacement. Force is ml t minus 2 into displacement ಇರೋದ್ರಿಂದ we get one more l, so we get ml square t minus 2 divided by t ಆಗುತ್ತೆ, or this is going to give us something like ml square t power minus 2 minus 1 ಆಗುತ್ತೆ. If we take this denominator t to numerator, minus 1 ಆಗಿರುತ್ತೆ, so t power minus 2 minus 1 will give us t power minus 3. Okay, so the dimension of impulse is ml t minus 1, whereas the dimension of power is ml square t minus 3. Okay, hope it is clear. Moving to next question. Yeah, so if at all some complicated or little difficult type of a question should be framed in this chapter for 2 or 3 mark. Okay, so some question can be framed like this. Okay, slightly difficult I can say only for this chapter level. Okay, compared to other questions this will be slightly difficult. So this can also be asked in 2 mark or 3 mark. Okay, so what are the dimensions of a and b in the relation f is equals to a root x plus bt square, where f is force, x is distance and t is time. So here we have to find out the dimensions of the term a and b, which is given in the equation f is equals to a root x plus bt square. Okay, so what we will do, first we will take down the given equation. So let me just write down f is equals to a root x plus bt square. Okay, so ಈಗ principle of homogeneity na apply ಮಾಡೋಣ. ಅಂದ್ರೆ ಏನು, the dimension of this force must be equal to the dimension of the term a root x, and also the dimension of bt square must be equal to the dimension of force ಆಗಿರುತ್ತೆ. Okay, so from principle of homogeneity ಏನು ಹೇಳ್ಬೋದು, the dimension of force must be equal to the dimension of a root x, and also the dimension of force must be equal to the dimension of the term bt square. Okay, so let us consider one by one. First I will consider the dimension of f is equals to a root x dimension. So you got dimension of force bariyana, that is ml t minus 2. Force is mass into acceleration, so ml t minus 2 into equals to the dimension of a, let me write as it is, into the dimension of root x. Okay, so ಇಲ್ಲಿ x ಅಂದ್ರೆ distance ಅಂತ ಇದೆ, so dimension L ಆಗುತ್ತೆ. ಇಲ್ಲಿ root x ಇರೋದ್ರಿಂದ I can write L raised to half. Root ಅಂದ್ರೆ to the power half. Okay, or this will give us the dimension of a will be equal to m L t raised to minus 2 whole divided by L raised to half. Or ಇದನ್ನ further simplify ಮಾಡಿದ್ರೆ we get a dimension. Okay, so we have to put the square bracket. So the dimension of a is equals to m. So ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ L raised to 1 ತರ, so L raised to 1 minus L raised to half ಆಗುತ್ತೆ, which is in the denominator. So we get L raised to half. 1 minus half is half. Okay, so m L raised to half t raised to minus 2 as it is. So this is the dimension of a. So similarly now we will try to find out the dimension of b. For that what I should consider, the dimension of s is equals to the dimension of bt square. So let me just write in the next page. So in consider ಮಾಡಬೇಕು, the dimension of f is equals to the dimension of bt square ಅಂತ ತಗೊಳ್ಳೋಣ. So again dimension of force is ml t minus 2 is equals to the dimension of b into t square andre again it's like m0 L0 t power 2. or if we just rearrange this, we get dimension of B is equals to, so in baratte M L T minus 2 whole divided by M0 L0 T power 2 agate, or this will simply give us dimension of B is equals to, so M L as it is, that is like M raised to 1 L raised to 1, illi T power minus 2 ide and denominator alli T power plus 2 ide, so that will give us T power minus 2 in the numerator, which is simply like T power minus 4. Okay, so this is the dimension of B. Okay, so dimension of B is ML T raised to minus 4, whereas the dimension of A is M L raised to half T raised to minus 2. Okay, so this can also be asked for 2 mark or sometimes for 3 mark as well. Okay, so now we'll just move ahead to the 3 mark question. So I can just simply say, like, in 2 mark for this chapter, any dimensions they can ask you to write down, or they may ask you to write down some fundamental quantities and fundamental units. Okay, some SI units they can ask you to write down. Such questions can appear in 2 mark. Also, you may be asked to write down the limitations and the applications of dimensional analysis. Okay, so those are the most expected questions for 2 mark. Okay, so coming to 3 mark question. So illi 3 mark alli usually application of dimensional analysis based questions irutte. Okay, one is to check the correctness of the equation, the other can be deriving the equation, and the another one can be converting unit from one system of unit to other system of unit. So mostly we can expect such type of questions, okay, for 3 marks in this chapter. So let us begin with this particular question. Check the dimensional correctness of the equation x is equals to V naught into t plus half at square, where the symbols having their usual meaning. Okay, so illenide ಒಂದು equation ಕೊಟ್ಟಿದ್ದಾರೆ. Okay, with the usual notations ಅಂತ mention ಮಾಡಿದ್ದಾರೆ. You might be familiar with this equation in motion in one dimensional chapter as well. Okay, so ಅದರ dimensional consistency na check ಮಾಡಬೇಕು. Okay, by using principle of homogeneity. So let us write down the given equation. So ಏನಿದೆ, x is equals to V naught into t plus half at square ಅಂತ ಇದೆ. ಸೊ ಇಲ್ಲಿ x ಅಂದ್ರೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್, V naught ಅಂದ್ರೆ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ, t ಅಂದ್ರೆ ಟೈಮ್, a ಅಂದ್ರೆ ಆಕ್ಸಿಲರೇಷನ್. ದಟ್ ಈಸ್ ಅವರ್ ಯೂಶುವಲ್ ನೋಟೇಷನ್. ಸೊ ಈಗ ಒಂದೊಂದೇ ಟರ್ಮಿನ ಡೈಮೆನ್ಷನ್ಸ್ ಬರೆಯೋಣ. ಸೊ ದ ಡೈಮೆನ್ಷನ್ ಆಫ್ ಈಚ್ ಟರ್ಮ್ ಮಸ್ಟ್ ಬಿ ಸೇಮ್. ದಟ್ ಇಸ್ ದಿ ಲಾಜಿಕ್. ಓಕೆ, ಸೊ ಫಸ್ಟ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಏನಿದೆ, x ಅಂತ ಇದೆ. ಸೊ ದ ಡೈಮೆನ್ಷನ್ ಆಫ್ x ಇಸ್ ಸಿಂಪ್ಲಿ ಲೈಕ್ m0 L t0 ಅಂತ ಬರೀಬಹುದು. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡ್ ಟರ್ಮ್ ಏನಿದೆ, V naught into t ಅಂತ ಇದೆ. V naught into t. ಸೊ ಅಗೇನ್ ಡೈಮೆನ್ಷನ್ ಬರೆದ್ರೆ, ಸೊ ಇಲ್ಲಿ V naught ಅಂದ್ರೆ ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ. ಸೊ ವೆಲಾಸಿಟಿ ಡೈಮೆನ್ಷನ್ ಏನು, m0 L t minus 1. Okay, so velocity dimension is m0 lt minus 1 into t ಅಂತ ಇದೆ ಇಲ್ಲಿ. ಸೊ ಅದರ ಡೈಮೆನ್ಷನ್ ಏನು ಬರೀಬಹುದು, m0 L0 t, or this is going to give us the dimension of V naught into t is simply like m0, here 1 L is there, here L power 0 is there, which is simply going to give us L. Okay, m0 L t raised to minus 1 is here, and here it is t power 1 is there, so which will just cancel out and gives us t power 0. Okay, m0 L power 1 t raised to 0. So that is for the dimension of second term. There is one more term, that is half at square. So illi this half is a number, dimension illa adike, it is just a number. So I'll consider the term at square. Okay, so the dimension of at square. So ಇಲ್ಲಿ a ಅಂದ್ರೆ acceleration, that is like m0 L t minus 2 into t square ಅಂದ್ರೆ again t power 2 ಆಗುತ್ತೆ, or this will give us the dimension of at square is equals to m0 L t power ಇಲ್ಲಿ minus 2 ಇಲ್ಲಿ plus 2 ಅಂದ್ರೆ will simply get t power 0. Okay, so ಇಲ್ಲಿ ಏನು ಹೇಳ್ಬೋದು, if you just observe the dimension of this x, dimension of V naught into t, and the dimension of at square. So we can clearly say that each term has a dimension like m0 l t power 0 ಇದೆ correct. So ಏನು ಬಂದಿದೆ ನಮಗೆ m0 l t power 0 ನ ಇದೆ dimension of each term. That means it is dimensionally correct. ಏನು ಹೇಳ್ಬೋದು, as the dimensions of these three terms are same, we can clearly say that it is dimensionally correct. Okay, dimensionally correct equation. Okay, we can say that it is dimensionally correct. Hope it is clear. We'll move on to next question in 3 mark. Again, one equation ಕೊಟ್ಟಿದ್ದಾರೆ and we have to find out the dimensional consistency. Okay, ಏನಿದೆ, check the dimensional correctness of the equation t is equals to 2 pi into root of L by G, where L is the length of the pendulum, t is the time period and G is the acceleration due to gravity ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. Okay, so ಈ particular equation ನ consider ಮಾಡಿ we had to find out the dimensional consistency. Dimensionally ಇದು correct ಇದೆಯಾ ಇಲ್ವಾ ಅಂತ. Okay, so let us consider the given equation, that is t is equals to 2 pi into root of L by G. Okay, so again term wise we will take and we'll write down their dimensions. So dimensions of each term same bantu andre it's clear that it is dimensionally correct. So left hand side alli enide t anta ide, so the dimension of t is simply like m0 l0 t power 1 agutte. So illi 2 pi is a number, no dimension, so I'll just write nd. So no dimension for 2 pi, it's just a number. And then we have the term like root of L by G there. So let us consider the dimension of root of L by G. Or ಇದನ್ನ ಹೇಗೆ ಬರಿಬೋದು, so what I'll do is L by G raised to power half ಅಂತ ಬರಿತೀನಿ. Okay, so ಹೇಗೆ ಬರಿಬೋದು, L by G raised to power half. So ಈಗ ಡೈಮೆನ್ಷನ್ ಬರಿತಾ ಹೋಗೋಣ. Okay, so L by G raised to power half in a dimension. So L ಅಂದ್ರೆ m0 L t0 divided by G andre, so acceleration due to gravity, which is nothing but going to have the dimension as acceleration itself, andre m0 L t minus 2 ಆಗುತ್ತೆ. Okay, so ಹೇಗೆ ಬರಿಬೋದು, the dimension of L by G raised to half is, so L andre m0 L t0 and G dimension, that is acceleration dimension ಏನಾಗಿರುತ್ತೆ m0 L t minus 2. Okay, so ಈಗ ಇಲ್ಲಿ simplify ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, so it is like this L and this L will cancel out. Okay, so ಆಗ again we get m0 L0 t power, so let me just write here, in ಬರುತ್ತೆ, this is going to give us m0 L0 t power plus 2 ಆಗುತ್ತೆ. ಈ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಇರೋದು ನ್ಯೂಮರೇಟರ್ ಹೋದ್ರೆ t power plus 2 ಆಗುತ್ತೆ. Okay, so yeah, here there is a rise to power half is there, sorry I just have left that, so rise to power half. Okay, so let me just write in the next page. So ಏನು ಬಂದಿದೆ ನಮಗೆ, L by G rise to power half is equals to m0 L0 t power 2 rise to power half ಇದೆ, or this is something like L by G rise to power half is equals to, so m0 L0 t power 1 ಆಗುತ್ತೆ. Okay, so t square rise to power half and it is nothing but t power 1. Okay, it is t square under root kind of a thing, which is nothing but t power 1. So ಈಗ if you just observe, so you can also call this as some equation 1 if you want. So illénide the dimension of time alva m0 L0 t antide, so ಅದೇ ತರ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಇನ ಇದೇನ್ ಬಂದಿದೆ ಡೈಮೆನ್ಷನ್ m0 L0 t power 1 ಅಂತಾನೆ ಬಂದಿದೆ. So I can call this as equation 2. So again it is correct, dimensionally correct equation. So ಏನು ಹೇಳ್ಬೋದು, correct equation, dimensionally correct. If you want to be more precise, it is dimensionally correct equation. Okay, so this is how we check the dimensional consistency. So just take the dimensions on left hand side and then take the dimensions of right hand side terms and then see if the dimensions are going to be same. Okay, if it is correct, the equation is consistent. If it is not same, that if the dimensions are different on left hand side or right hand side or with the two different terms in the given equation, so then it is dimensionally incorrect. Okay, so this is another question for 3 marks. So hope it is clear. We'll now move on to the next question, that is derive the expression for period of simple pendulum which depends on its length L, acceleration due to gravity G using the dimensional analysis. Okay, so this is a reverse process. So previous question al enittu, so we were given with the time period of simple pendulum and we were asked to check whether it is correct or not. So ee question al enide, by using the dimensional method we had to arrive at the equation for the time period of simple pendulum. This is the second application of your dimensional analysis. So we had to derive the expression for time period of simple pendulum. So time period of simple pendulum na capital T anta tagolana. Okay, and it is assumed to be depending on the length of the pendulum L, acceleration due to gravity G anta kottidare. Okay, so if we now write it in the equation form, hege baribodu, that is the time period of the pendulum, okay, is equal to, or first we'll take proportionality, let us say. Okay, so first right now we don't know on what powers of L and G this time period is going to depend, so that's why we put a proportionality symbol there. So T is proportional to, I can say, L raised to X and G raised to Y anta tagolana. Okay, or proportionality idre adu equation al baribekadre ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ನ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡೋಣ. So I'll take that as K. So T is equals to K into L raised to X, G raised to Y anta tagolana. Okay, so this is what we are considering as the time period equation for a simple pendulum. So now our job is to find out on what power of length the time period is going to depend, and the X value find out ಮಾಡಬೇಕು, and on what power of G, that is acceleration due to gravity, that is nothing but Y value find out ಮಾಡಬೇಕು, X and Y value find out ಮಾಡಬೇಕು. Okay, so for that we will now write down the dimensions of all the terms and we can equate them, and if the bases are going to be same, then we can also equate the powers. That's what the method we do here. So let us try to write down the dimensions of each term. So left hand side alli enide T, that is time period andre M0 L0 T anta baribodu. Okay, is equals to, so this is a dimensionless constant, so right now I'm not considering that. Illi enide next L raised to X anta ide, so L andre M0 L T0 raised to power X, and then we have G raised to Y, andre acceleration due to gravity raised to power Y ide. So dimension of acceleration due to gravity is M0 L T minus 2 raised to power Y as it is. Okay, acceleration due to gravity andre it is nothing but going to have the dimension as acceleration, MLT minus, I mean M0 L T minus 2 ne irutte. Okay, or this can be further regrouped, that is M0 L0 T is equals to, so again ಮಾಡೋಣ MLT ನ separate ಮಾಡಿ ಬರೆಯೋಣ. Okay, so ಇಲ್ಲಿ M0 ಇದೆ, ಇಲ್ಲೂ M0 ಇದೆ, so I can just say 0 into X is 0, ಇಲ್ಲಿ 0 into Y is 0, so M power 0 ನೇ ಇರುತ್ತೆ. Okay, so next L consider ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ L raised to X ಇದೆ, ಇಲ್ಲಿ L raised to Y ಆಗುತ್ತೆ, so we can write L raised to X plus Y. Okay, ಅದೇ ತರ ಟೈಮ್ ಟರ್ಮ್ ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ 0 into X will give us 0, ಇಲ್ಲಿ minus 2Y ಆಗುತ್ತೆ. Okay, so ಈಗ left hand side in a terms and right hand side in a terms na, if the bases are same we can equate their powers alva. So illi M raised to 0 ide, illu M raised to 0, illi you can also write like X. Okay, and you can say like X is equals to 0. Okay, so if we just write down one term here, there is no dependency on mass. Okay, so that we can say. Next we have the second term, so that is L ರೈಸ್ ಟು x plus y ಇದೆ, ಇಲ್ಲಿ L ರೈಸ್ ಟು 0 ಇದೆ. ಸೊ ಏನ್ ಮಾಡ್ಬೋದಾಗ we can say x plus y must be equal to 0. ಓಕೆ, ಅದೇ ತರ ಇಲ್ಲಿ -2y ಇದೆ, ಇಲ್ಲಿ t power 1. ಸೊ ಏನ್ ಈಕ್ವೇಟ್ ಮಾಡ್ಬೋದು? ಸೊ ಲೆಟ್ ಮಿ ರೈಟ್ ಹಿಯರ್ -2y is equals to 1 ಆಗತ್ತೆ. ಓಕೆ, ಸೊ ಎರಡು ಸೈಡ್ ಅಲ್ಲಿ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಬೇಸ್ಗೆ ಏನ್ ಪವರ್ಸ್ ಇದೆ ಅದನ್ನ ಈಕ್ವೇಟ್ ಮಾಡೋದು. ಓಕೆ, ಸೊ ದಟ್ಸ್ ವಾಟ್ ವಿ ಆರ್ ಡೂಯಿಂಗ್. ಸೊ ಈಗ ಇಲ್ಲಿ -2y is equals to 1 ಅಂದ್ರೆ y ಏನ್ ಬರುತ್ತೆ? y is -12 ಬರುತ್ತೆ. ಓಕೆ, y ವ್ಯಾಲ್ಯೂ -12 ಬರುತ್ತೆ. ಸೊ ಅದನ್ನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ, ಓಕೆ, ಸೊ ಏನು x plus y is equals to 0 ಇದೆ. 1 minute. Here there is a small mistake. Sorry, I cannot say x is equals to 0 because this is a wrong sentence. Here there is no dependency on, you know, x there on mass. 1 second. Yeah. So this is totally m raised to 0. Okay. Yeah, m raised to 0. Okay. So here also 0 is there. So 0 into x and 0 into y irodalli. So it is m raised to 0 itself. Okay. There is no dependency on mass at all. Okay. So that's the meaning. So we cannot able to write m goes to 0. Okay. So then we have one more, that is from the length we have x plus y is equals to 0. And then we have in terms of time we have -2y is equals to 1 baratte. So which will give us y is equals to -12. So ಈಗ y value na ಇಲ್ಲಿ substitute ಮಾಡೋಣ. Okay. So let me just write in the next page. So ಏನು ಬಂದಿದೆ ನಮಗೆ? x plus y, 1 second. Yeah. So there is some issue with the writing space. Just give me a second. Yeah. So x plus y is equals to 0 ಇದೆ. So x value we had to find out, but y value ಏನು ಬಂದಿದೆ ನಮಗೆ? -12 ಅಂತ ಬಂದಿದೆ. Or this will give us x is equals to +12 ಆಗತ್ತೆ. Okay. So x is equals to +12 and y is equals to -12. ಸೊ ಈಗ ಇಲ್ಲಿ ಜಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಆಯ್ತು. ಟೈಮ್ ಪೀರಿಯಡ್ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ L ರೈಸ್ ಟು x ಇರೋದು G ರೈಸ್ ಟು y ಇದೆ. ಸೊ ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. ಏನ್ ಬರಿಬಹುದು? ಸೊ ಟೈಮ್ ಪೀರಿಯಡ್ t is equals to some constant into L ರೈಸ್ ಟು x ಅಂದ್ರೆ L ರೈಸ್ ಟು +12 into G ರೈಸ್ ಟು y ಅಂದ್ರೆ G ರೈಸ್ ಟು -12 ಆಗುತ್ತೆ. Okay, again we can just write it in the square root notation. So rise to half andre square root, -12 andre that comes in the denominator anta artha. So t is equals to some constant into square root of L by G anta baribodu. Okay, square root of L by G. So the constant, the proportionality constant that comes in this particular equation is 2 pi. Okay, so final equation no, we get t is equals to 2 pi into root of L by G ಆಗಿರುತ್ತೆ. But by the method of dimension we don't get the value of 2 pi. Okay, so that should be experimentally determined. So here you can just stop at this point for 3 marks. Time period t is equals to k into root of L by G. Okay, is that clear? So this is how we derive the expression for time period of a simple pendulum by using the dimensional analysis method. Okay, so here is one more question for 3 marks, that is the centripetal force F acting on a particle moving uniformly in a circle depends upon its mass m, velocity v and radius r. Derive the expression for centripetal force using the methods of dimensions. Okay, so again dimensional method in the we had to derive the expression for centripetal force. Okay, yavudakke centripetal force ಗೆ expression derive ಮಾಡಬೇಕು by assuming it is going to depend on the mass, velocity and radius of the circle. m v r ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿದೆ ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡಿ we had to obtain the expression for centripetal force. Okay, so illi again centripetal force andre, in a circular motion, the direction of this particular force will be always towards the center, and that's why we call it as centripetal force. But whatever may be the type of the force, okay, they may give you like Coulomb force, gravitational force, whatever. So force is going to have the dimension of mlt minus 2. Any type of force they mention, force is a force, and hence their dimension is always mlt minus 2. Okay, so that we should know. So first we'll just write down an expression by saying that force is going to depend on m raised to x, mass raised to x, velocity raised to y, and radius raised to z. Anta assume madoಣ. Force, the centripetal force is proportional to m raised to x, v raised to y, r raised to z. So currently I don't know on what power this force is going to depend on mvr. So our job is to find out the value of this x, y, and z. Okay, or equation form andre ಏನು ಮಾಡ್ತೀವಿ? So we just write down force F is equals to some constant of proportionality na introduce ಮಾಡೋಣ. So F is equals to K into m raised to x, v raised to y, r raised to z ಆಗುತ್ತೆ. Okay, yeah. So ಈಗ dimensional notations ಅಲ್ಲಿ ಬರಿತಾ ಹೋಗೋಣ. So we can say the dimension of force F must be equal to the dimension of m raised to x antide. So mass in a dimension I can simply write like m L0 T0 raised to power x. Next is the velocity. So velocity is like LT minus 1 raised to power y ಆಗುತ್ತೆ, and r raised to z. So r andre illi radius, that is nothing but going to have the dimension as length L. So m0 L T0 anta baribodu. m0 L T0 raised to power z. Okay, so this is how to write the dimension. Yeah, we can also write on the dimension of force. Okay, I'll just write here itself the dimension of force. So in baribodu, that is force andre m L T minus 2. Okay, mass into acceleration. So we can say ml T minus 2. Dimension of force is ml T minus 2. Okay, so that minus may not be visible, so I'll write here. Okay, mlt minus 2. So ಈಗ further regroup ಮಾಡೋಣ. The dimension of force, that is ml T minus 2 is equals to, ಈಗ mass, length and time terms na separate ಮಾಡಿ ಬರಿತೀನಿ, so that it becomes easy while equating their powers. Okay, so ಇಲ್ಲೇನಿದೆ m raised to x ಆಗುತ್ತೆ. Okay, so m raised to x. So illi m term illa, velocity alli illa, and here also there is no mass dependency. So I can simply say m raised to x. So next length term tagondre, so illi enide 0 ide, so that will not come. Here it is like L raised to 1 into y, which will give us y, and here also L raised to 1 into z, which will give us z. So ಏನು ಬರುತ್ತೆ ನಮಗೆ L raised to y plus z ಆಗುತ್ತೆ. Okay, ಅದೇ ತರ ಟೈಮ್ ಟರ್ಮ್ ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ t power 0 ಇದೆ, so that term will not come. ಇಲ್ಲೇನಾಗಿದೆ t power minus 1 into y will give us minus y. Okay, this is minus y, and then here t power 0 is there, so 0 into z will not come. Okay, so now we can compare their bases. Okay, bases same ಇದೆ, we can equate their power. So ಇಲ್ಲೇನಾಗಿದೆ m raised to 1 ಇದೆ, ಇಲ್ಲಿ m raised to x ಇದೆ. So from that we can clearly say x must be equal to 1. Okay, so ಇಲ್ಲಿ ಏನು ಇಲ್ಲ ಅಂದ್ರೆ 1 ಅಂತ ಅರ್ಥ. 0 ಇದ್ರೆ we will write it as 0, right? Or we don't mention the term at all. So m andre m raised to 1. Okay, so ಇಲ್ಲಿ x ಇದೆ, so x should be equal to 1. So next ಇಲ್ಲಿ L raised to 1 ಇದೆ, ಇಲ್ಲಿ y plus z ಇದೆ. So ಏನು ಹೇಳ್ಬೋದು, y plus z must be equal to 1. And illénide t raised to minus y ಇದೆ, ಇಲ್ಲಿ minus 2 ಇದೆ. So from that ಏನು ಹೇಳ್ಬೋದು, minus y must be equal to minus 2, or this will give us y is equals to plus 2 ಆಗುತ್ತೆ. ಓಕೆ. ಸೊ ಈಗ y is equals to plus 2 ನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ. ಏನಾಗುತ್ತೆ, 2 plus z is equals to 1, or this will give us z is equals to minus 1 ಆಗುತ್ತೆ. ಓಕೆ. ಸೊ ಏನು ಹೇಳ್ಬೋದು, z is equals to 1 minus 2 ಅಂದರೆ minus 1. ಓಕೆ. ಸೊ x is equals to 1, y is equals to 2 and z is equals to minus 1 ಇದೆ. ಸೊ ಈಗ ಈಕ್ವೇಶನ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೆಯೋಣ. ಸೊ ಲೆಟ್ ಮಿ ಜಸ್ಟ್ ರೈಟ್ ಇನ್ ದಿ ನೆಕ್ಸ್ಟ್ ಪೇಜ್. ಸೊ ಏನಾಗಿದೆ, f is equals to k into m raised to x, v raised to y, r raised to z ಅಂತ ತಗೊಂಡಿರೋದು. ಸೊ we will just rewrite that first. ಸೊ ಏನು ತಗೊಂಡಿದ್ದೀವಿ, ಫೋರ್ಸ್ f is equals to one second. Yeah. Force F is equals to, so when we just change the pages, it is fluctuating. Just give me a second. Yeah. Force F is equals to K into M raised to X. Okay. And then we have velocity raised to Y. And then we have R raised to Z. Correct? So M raised to X, V raised to Y, R raised to Z ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ. ಅಂಡ್ ಈಗ ಎಕ್ಸ್ ವೈ ಝೆಡ್ ವ್ಯಾಲ್ಯೂ, ಎಕ್ಸ್ ಅಂದ್ರೆ 1, ವೈ ಅಂದ್ರೆ 2, ಝೆಡ್ ಅಂದ್ರೆ -1. ಓಕೆ. ಸೊ ವಿಲ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಹಿಯರ್. ಎಫ್ ಇಸ್ ಈಕ್ವಲ್ಸ್ ಟು ಕೆ ಇಂಟು, ಸೊ ಎಮ್ ರೈಸ್ ಟು ಎಕ್ಸ್ ಅಂದ್ರೆ ಎಮ್ ರೈಸ್ ಟು 1. ಓಕೆ. ವಿ ರೈಸ್ ಟು ವೈ, ಸೊ ವೈ ಅಂದ್ರೆ ನಮ್ಗೆ ಏನು ಬಂದಿದೆ, 2 ಅಂತ ಬಂದಿದೆ. ಓಕೆ. ಸೊ ವೈ ಇಸ್ 2 and r raised to z andre -1 anta bandide, or this can be rearranged as f is equals to some k into m v square will keep in the numerator itself. ಅಲ್ಲಿ ಏನು ನೆಗೆಟಿವ್ ಪವರ್ ಇದೆ ಅದನ್ನ ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ ಬರೆಯೋಣ. ಓಕೆ. f is equals to k into m v square by r ಅಂತ we will get. Okay. So ಇಲ್ಲಿ this constant of proportionality in SI system is 1. Okay, so we simply get like f is equals to mv square by r. Okay, so this is the actual formula for centripetal force, mv square by r. You can just stop at this point. Okay, or you can say the value of constant k here is 1, so we simply get f is equals to mv square by r. Okay, so this is how we derive the expression for centripetal force, which assumed to be dependent on mass, velocity and radius. Okay, by using the dimensional analysis method. So here our job is just to write down there, the dimensions of each and every physical quantity that is given, and then we have to separate, the mass, length, time separate terms madkondre. Then we have to equate their, the powers. If the bases are same, equate their powers on left hand and right hand side. Okay, so that is going to give you the unknown powers like x, y, z. Okay, hope it is clear. We will move on to one more question, that is convert 1 Newton into dyne, CGS unit of force. So illi Newton andre this is SI unit of force, correct? We know that Newton is the SI unit of force, whereas this dyne is the CGS unit of force. So now we have to convert 1 Newton into dynes. So 1 Newton is equals to how much of dyne, that is what we are supposed to find out. This is another application of your, the dimensional analysis, converting unit from one system to other system. Okay. So basically any physical quantity, we know that this is going to have its, size or magnitude or some numerical value. So n into its unit, correct? Physical quantity, we write it as q is equals to n into u anta bariತೀವಿ. Okay, so ಈಗ ಇಲ್ಲಿ ಎರಡು ಸಿಸ್ಟಮ್ ಇದ್ದಾಗ whatever I measure, that must be same. The amount of, that particular force or whatever may be the physical quantity must be same irrespective of the system of units. Okay, the amount or the quantity of that substance will remain the same. The physical quantity remains the same. ಅಂದ್ರೆ ಹೇಗೆ ಬರಿಬಹುದು, that is like n1 u1 is equals to n2 u2 ಅಂತ ಬರಿಬಹುದು. Okay, where n1 is the value in system 1 and n2 is the numerical value in the, second system of unit. Okay, so illen assume marana, this u1 let us assume like SI system. Okay, and this u2 let us assume like CGS system. Okay, so these are all, I'm just giving you the explanation. You no need to write down all this. You can just straight away start from n1 u1 is equals to n2 u2. Okay, or I'll just rewrite this way, that is n2 u2 is equals to n1 u1 anta tagoltini. Okay, and before that we had to know the dimension of force. Okay, so force in a dimension ಗೊತ್ತಿರಬೇಕು. So I'll just write here itself, the dimension of force is equals to ml t minus 2. In general the dimension of force ಹೇಗೆ ಬರಿತೀವಿ, ml t minus 2 ಅಂತ ಬರಿತೀವಿ. Okay, so ಈಗ ಎರಡು system of units we are considering. One is SI and the other is in the CGS unit. So let us assume like M1 L1 T1. Okay, M1 L1 T1 with the mass, length and time in the first system, that is in SI anta tagolana. Okay, and we will say M2 L2 T2 in the CGS system. Okay, the corresponding mass, length, time in the CGS system I am taking it as M2 L2 T2. So ಈಗ ಇಲ್ಲಿ rewrite ಮಾಡ್ತೀನಿ. Okay, so I don't know the value of n2 which I am interested to find out. So n2 ಹಾಗೆ ಬರಿತೀನಿ. So u2 ಅಂದ್ರೆ ಏನು ಮಾಡಿ ಬರಿಬಹುದು ಈಗ, because here I am talking about the the unit Newton which is the unit of force. So ಅದರ dimension notation ಅಲ್ಲಿ ಬರಿತೀನಿ. ಹೇಗೆ ಬರಿಬಹುದು, so m2 L2 T2 raised to minus 2 ಆಗುತ್ತೆ, because ಇಲ್ಲಿ mass, length, time ನ m2 L2 T2 ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ second system or CGS ಅಲ್ಲಿ, and dimension ಏನಿದೆ mlt minus 2 ಇದೆ. So we can write like m2 L2 T2 raised to minus 2. Okay, is equals to n1 ಅಂದ್ರೆ ಇಲ್ಲಿ ಎಷ್ಟು ಕೊಟ್ಟಿರ್ತಾರೆ ಅದನ್ನ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. So ಇಲ್ಲಿ 1 Newton ಇದೆ, sometimes they may ask you like 10 Newton, 50 Newtons or some random number they will give you. So here it is simple, n1 must be taken as 1. Problem alle 1 anta kottirodrinda. Okay, so what I will do, I will just put 1 into u1 andre again m1 L1 T1 raised to power minus 2. Okay, so iga further ಏನು ಮಾಡ್ಬೋದು, n2 is equals to, so I'll just rewrite that as m1 L1 T1 raised to minus 2 whole divided by m2 L2 T2 raised to minus 2. Okay, so ಈಗ corresponding system ಅಲ್ಲಿ ಅದರ units ನ consider ಮಾಡೋಣ, units of mass, length, time in SI and CGS system, and we'll substitute here. Okay, so ಅದನ್ನ next page ಅಲ್ಲಿ ಬರಿತೀನಿ. Okay, so ಏನು ಮಾಡಬೇಕು, ಇಲ್ಲಿ m1 L1 T1 ಅಂದ್ರೆ ಏನು, that is the mass, length, time in SI system. So corresponding unit ಏನಾಗುತ್ತೆ, so mass ಅಂದ್ರೆ kg, length ಅಂದ್ರೆ ಮೀಟರ್ ತಗೋಬೇಕು, and t raised to minus 2 ಇದೆ, so time is second, so second minus 2 ಆಗುತ್ತೆ. So if we just write down that, so ಏನು ಬರುತ್ತೆ ನಮಗೆ, n2 is equals to, okay, so kg meter second minus 2 whole divided by, so illénide m2 L2 T2 raised to minus 2 ಇದೆ. So this is corresponding to CGS system, right? We have assumed like a CGS system. So CGS ಅಲ್ಲಿ mass is measured in grams, length is measured in centimeter and time in second. So ಅದನ್ನ ಇಲ್ಲಿ substitute ಮಾಡ್ತೀನಿ, gram centimeter second minus 2 ಆಗುತ್ತೆ. Okay, so ಇಲ್ಲಿ ಏನು power ಇದೆ that we had to consider. Okay, if I had like m square, then I had to write kg square. L square term idre I had to write like meter square or centimeter square depending on SI or CGS. ನೋಡ್ಕೊಂಡು ಬರಿಬೇಕು. So mlt minus 2 ಇರೋದ್ರಿಂದ ಏನು ಬರ್ದಿದ್ದೀನಿ, kg meter second minus 2 in the numerator and gram centimeter second minus 2 in the denominator ಆಗುತ್ತೆ. So ಇದನ್ನ ಸ್ವಲ್ಪ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೋದು ಈಗ. So kg ಅಂದ್ರೆ ಏನು, it is like 10 power 3 grams ಅಂತ ಹೇಳ್ಬೋದು. Correct, kilogram is like, kilo means 10 power 3. Okay, or we know that 1 kg corresponds to 1000 grams, which can be written as 10 power 3 grams. Okay, and illi meter anta ide, so we know that 1 meter is 100 centimeter, or we can just write like 10 power 2 centimeters. Okay, 10 power 2 centimeters agate. Okay, so that if units are same, we can cancel. Okay, we get the numerical value. So that's why I'm converting kg to grams, meter to centimeter, and second minus 2 we can keep as it is, because seconds is same in both CGS and SI system. Okay, denominatorly gram, centimeter, second minus 2 ಇದೆ. Okay, so ಈಗ ಇಲ್ಲಿ this and the centimeter, the second minus 2, and the other second minus 2 will cancel out. So n2 andre ಏನು ಬರುತ್ತೆ ನಮಗೆ ಈಗ, so we are just left with 10 power 3 into 10 power 2 ಇದೆ, that is 10 power 3 plus 2, which is nothing but 10 power 5 ಆಗುತ್ತೆ. Okay, so ಏನು ಬರುತ್ತೆ 10 power 5. So n2 value is 10 power 5. ಅಂದ್ರೆ ಏನು ಹೇಳ್ಬೋದು, 1 Newton, okay, is equals to 10 power 5 dyne anta helbodu. Okay, so this is how we convert Newton to dynes, or any other physical, any other units from one system to other, system of unit ge convert madbekandre, consider their dimension and use n1 u1 is equals to n2 u2 formula. Okay, so this is the basic formula. Okay, so again ಇಲ್ಲಿ ಏನು ಬರೆದಿದ್ದೀವಿ, n1 ಅಂದ್ರೆ 1, u1 ಅಂದ್ರೆ ನ್ಯೂಟನ್. ಸೊ 1 ನ್ಯೂಟನ್ is equals to n2 ವ್ಯಾಲ್ಯೂ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದೀವಿ, ಏನು ಬಂದಿದೆ ನಮಗೆ 10 power 5. u2 ಅಂದ್ರೆ CGS system ಇನ ಫೋರ್ಸ್ ಯೂನಿಟ್ ಏನಿದೆ ಡೈನ್. So this is how we convert 1 Newton to dyne. So 1 Newton is not equal to 1 dyne, 1 Newton is equals to 10 power 5 dynes. Okay, hope it is clear. So this is the another application of dimensional analysis. Okay, find out the given unit corresponds to which physical quantity. So other dimension anna bardu, so you have to follow these steps. Okay, so this is one probable question for 3 marks. Okay, so till now, we have discussed certain expected questions in 2 marks and 3 marks from the chapter of units and measurement. Okay, hope it is helpful for you to revise once, the questions, once to practice with every questions. Okay, and as question and answers are together, it may be even helpful, to crisp your answers. So particular question ಗೆ ಏನು ಆನ್ಸರ್ ಬರಿಬೇಕು ಅನ್ನೋದು ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. So hope you have liked this session, and if you have understood, please like this session and also subscribe to our channel for more content. Okay, thank you.